today. It is going to be October, November 2022. Okay. And this is paper 3, variant number 4. Let us go for question 1. In this experiment, you will investigate the stability of a cylinder. Use some of the sheets of paper to make a pile of approximate thickness 3 millimeter. So you are given, okay, a sheets of paper, and you were asked to put them over each other or make a pile of them with a thickness of 3 millimeters. Okay? Most probably you are going to be given a vernier to carry this measurement. Okay, here it is. Using the calipers, vernier calipers, measure and record the thickness T of the pile. Okay. Whenever you get this structure of question, you are asked to carry a measurement. You are asked to carry a what? A measurement. Always take 2 measurements. Always take what? 2 measurements. Okay? For example, we have a pile of papers. We have a vernier. Then using the vernier, we are going to measure this pile of paper such that their approximate thickness is 3 millimeter. It doesn't have to be exactly 3 millimeters. Okay? Then show that you have taken at least 2 values for the thickness. This is important. This is important. Always show him that you have taken 2 values for the thickness. So for example, you carried the first measurement and it was 3.22 millimeter. You took out the vernier, you moved it into another direction or some other part of the pile, and you took another measurement for the thickness, 3.20 millimeter. You took 2 readings. So, which reading should I report?
I can make the average.
Yes, exactly. So, it is very important to get a full mark in such questions. Always show him that you have taken 2 readings and you are reporting the average. Okay? So, the average is going to be 3.22 plus 3.20 divide 2. It is going to be 3.21. And we have to put the units. Don't forget the units. Okay?
Okay.
Now, let us proceed further. So, position the apparatus on the bench as shown. He asked us to put the things on the bench as shown. Measure and record the width of the board as shown in figure 1. So this is the width of a board. It's going to give you a board, okay, a wooden board, and he's showing you the width where you should take the measurement. Again, emphasize that you have taken 2 measurements for the width. Okay? Again, which one are going to report? Are going to report the average. For example, I did the measurement myself and my centimeter and 25 centimeter. Okay? So using the meter ruler they are giving me or the 30 centimeter ruler I have. Okay? Then what I'm going to do, one measurement in one direction, move a little bit, take another measurement for the width. So I got this measure. This is average. What is the average, Deem?
29.3 plus
Yes.
9.9 divided by 2.
Okay, divide 2, you are going to get 29.6 centimeters. Okay. Use the stand and clamp to hold the rule, the meter rule or the meter rule vertically on the bench. So this is a meter ruler. Okay, so he instructed us to put this experiment together. Today we are not going to exactly put it together. We'll leave this for later. Okay. Now what did he tell us? Measure and record the height Z of the raised end of the board when the bottle rolls over the pile of paper. So what you are going to do? You are going to slowly raise this board. Okay? Slowly raising it up till you get a point when this bottle just start sliding. The bottle will just start sliding. This is the distance or the height. Then you are going to record it one time. Repeat it another time. Okay, again, put it down. Put the setup again, right from the beginning. Slowly start rising it up till it starts to roll. And take a measurement of that again. Then we report the average. It's going to be 18.2 centimeter. Units are essential. Now, calculate theta using this relation. Then, sine minus 1. We know that it is 18.2. We know W is 29.6. Okay. Make sure these are compatible. So if it is centimeter, you are dividing by centimeter, right? Okay.
Yes.
Now we do the calculation. So it is shift sine minus 1, 18.2 divide 29.6 equals 37.9. degree. So it is quite enough to report two significant figures. Okay, so then I'm going just to decide to write it as 38 degrees. Always make sure in the calculator it is on degrees and not radians. Okay? When using the calculator, calculate the sine and any other trigonometric function, make sure you are using the degrees and not radians. Do you know how to make sure that you are using degrees and not radians?
Sine 90.
No, the easiest is sine 30. You get 0.5.
Okay.
So the easiest is just sine 30, you get 0.5. Sine 90, you should get 1, right?
Yes.
Is also okay. Sine 90, you should get 1. Fine. Okay, good. So we did the calculation and measurements, and we are fine. So now he's telling us we should follow the instructions very closely. Okay? Change the number of sheets of paper in the pile. Measure T and Z. Repeat until you have 6 sets of values of T and Z. Okay? You are going to take a measurement of t. What is t? This is t. Okay, meaning that we are going to vary the number of sheets of paper. And each time we are going to raise it a little bit slowly or slowly till it's starting to roll. As we increase the number of sheets of paper, the height Z will also increase. Okay? So T is here millimeters. Millimeter. Z is in centimeters. Now, we repeated the experiment 6 times. We repeated the experiment 6 times. Or we got 6 sets of measurements. 1, 2, 3, 4, 5, 6. For different T and for different Z, as instructed. Repeat until you have 6 sets of values for T and Z. Okay. We have to complete the table. Record your results in a table. Include values of theta and cosine theta in your table. Give your values of cosine theta to 3 significant figures. So the first thing we have to do to complete this is to calculate theta. Right? What is the unit for theta?
Degree.
Degree. And we have to get cosine theta. Cosine theta doesn't have units. So how do we calculate theta? He instructed us, this is how we calculate theta. Okay? It is sine minus 1, Z divided by W. W is constant, right? We calculate it in this part. This is W.
Yes.
So it is always going to be the same. So it is sine minus 1 Z divide 29.6. Okay, so we do the calculation. Just one for you to see it as we did before. Okay, so it is sine minus 1, 14.8 divide 29.6 equal 30. It is 30 degrees. We do the same for the others. It is 37.94, 44.10, 54.84, 56.91, and 61.86. To complete the table, we were asked to calculate the cosine. Right? Then I say cosine 30.866, and we were instructed to retain 3 significant figures. So it is 0.866, 0.789. Okay, 0.718, 0.576, 0.546, 0.471. Is this fine with you?
Yes.
Are you following?
Yes.
Okay, good. Now, make sure. Now we go to the other step. Now, plot a graph of, he's going to instruct us. Plot a graph of cosine theta on the y-axis against t on the x axis. So we have cosine theta in the y axis and t on the x axis. So the best thing to do is come over here, say x axis, y axis. Okay, just to remind yourself. Always try to use a pencil when you are writing or filling the tables, okay? Draw a straight line, determines the gradient and intercept. We are going to come to that later. Okay, so let me go to the part. Move this a little bit. Over here. Let us see. So we have over here, we have the x-axis, right? What is the unit of the x-axis? Sorry, the label is t. What are the units over here?
Millimeter.
Millimeters. Okay. What are the units? What we are going to put on the y-axis? Cosine theta. And we don't have units over here. Okay. Now, for the x-axis, we have a minimum of 2 and we have a maximum of 8.6 approximately. So should we decide and start from a 0 or start from another value? What do you think?
We can start from 2.
Sorry?
We can start from 2.
Okay, let us see. Let us see and work it together. Okay? So let us start from 0. We have 0, 1, 2, 3, 4, 5, 6, 7, 8. So if we start like this, we have 8.5. 8.5 is going to be over here. So this is not going to be a good scale. This is not going to be a good scale. We don't allow any value to goes outside
We can start from 1.
Sorry?
We can start from 1.
Yes, we can start from 1. It is an easy and good choice. Okay. Let me just walk you through a little bit how I can get, well, this doesn't, we are going to do it for the x-axis. So we are going to start from 1. Just 2, 3, 4, 5, 6, 7, 8, and this is 9. So we are good. Okay. Now let us go for the y-axis. So what about the y-axis? We have a minimum 0.471
Minimum
and
of
a maximum.
30.
Sorry? What did you say?
Okay, yes.
So we have a minimum of 0.471 and a maximum of 0.866. Right? So what if we start from 0? So what we are going to do is, if you would like to get a scale for 0, it is going to be 0.866 divide 12. 0.07, right? 0.07 is
Yeah.
not a good choice of a scale. What is the next best one?
0.01.
No.
0.1.
0.1. 0.1. Okay? So if we say it is 0.1, this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and this is 0.9. So the minimum over here is something like here, right? The maximum is going to be around here, right? In the
Yeah.
y-axis. It is between here and this one. If we draw the line, it's going to be something like this. Is it a good one?
No.
No. It is just very tiny part of the graph plot. So this is not a good choice. So we decide not to start from 0. Okay. What we are going to do is do this calculation. 0.4 or 0.47. Oh, sorry. Maximum minus minimum divide 12. There's going to be 0.866 minus 0.471 divide 12. Let me see what I'm going to get. 0.866 minus 0.471 divide 12. Going to get 0.032. 0.0329. Is it a good choice?
No.
No. What is the next best one?
0.03.
No. We don't take 0.03. 0.03 is not a recommended one. 0.04,
0.02.
multiples of 3, multiples of 4, multiples of 6, multiples of 7 are not good ones. So
No,
what?
0.02.
Sorry?
0.02.
If we are going to get 0.02, you will get, keep getting out of time. Okay? 0.02, you are going to still have a long way to go over the graph, right? Try 0.02 on yourself, okay? But the best one, it is always the highest. It's going 0.05. 0.0 what?
5.
5, okay. So I'm going to start here from 0.4. The next one, 4 what?
5.
5, 45. The one after,
0.50.
50, 55,
5.
0.60, 0.65, 0.70, 0.75, 0.80, 0.85, 0.90, 0.95. Okay?
Okay.
Now we get the first one. It is 2.01. 2.01. And for the x, for the y, we get 0.866. Okay, let us start. So this is 2, right? What is the next one?
I can see that is a table.
No, I mean, if we have this 2, okay? This line is 2 on the x-axis. What is the next smallest line?
2.1.
2.1, right? So this is 2.1. The another one is 2.2, so on and so forth, right? This is good.
Yes.
Okay, we have 2.01. So it is almost 2, right? This is 2,
Yes.
this is 2.01, so it is 2. What is 0.866? It is up here. So this is 2. We can mark it a little bit like this. So this is 2. So the line is equal to 2. Now, 1.866. Do you know how to get it? So what?
يعني every square is 0.05.
0. No. Each small
No,
square.
I will write 0.05 divided by 10.
Yes, 0.05. So each one is 0.005, right?
Yes.
Okay. So how are you going to do the counting? So this is 85. 8. This is 0.85, right? The one next to it,
Yes.
0.855. What is the other one? 0.860, right?
Yes.
Okay. This one, next one is
6.5.
0.865. Okay. The other one, 0.870. So it is between this one and that one, right?
Yes.
Okay, good. Something like here. Let me show you another way to do the calculation. Okay. So we have, so you're going to develop your own style. As you practice, you're going to develop your own style. But for example, I would like to represent 0.866. Okay. I know 0.866 is above the 0.85, right? Then I'm going to do this calculation. 0.866 minus 0.85. I divide by the scale, which is 0.05. Okay? What I'm going to do, this is the point I would like to represent. 0.85 is the closest to it. I divide by 1. I divide by the scale. Let me get the calculator. So 0.866 minus 0.85. This is the closest to it. Divide. 0.05. This is the scale. What I am going to get? How much I'm getting?
0.32.
0.32. Okay. What is important for me first is this number. This is
3.
going to tell me how many small squares I need to count up. Okay.
Okay.
Okay. Then it is going to be what? This is 1. This is 2. This is 3. But it is 32. It is telling me it is between 3 and 4. But it is closer to 3 than 4. Okay? Then I just come over here.
Okay.
So I count 1, 2, 3. Okay, and I just come over here a little bit. Can you see it?
Okay.
Okay?
Yes.
So there is no one way which is right and wrong. Just go with what you think is more comfortable for you. If you
And
think,
Mr.
sorry?
And if it was 39, I will round it to 4 or no?
Yes, yes. If it is 39, it is just going to be your own decision. Okay? So you are going to, for
Okay.
example, 39. Okay, this is the best I can do. 35, it is going to be something like this or here in the middle. Okay?
Okay.
Now let us see 0.789. So 0.789, it is going to be above here, right? Going to be 0.789 minus 0.75 divide 0.05. 0.789 minus 0.75 divide 0.05. 0.78. Okay? Then it is almost 8 small squares. 8 small squares. What I'm going to count? This is 3,
8,
right?
4,
3.1, 3.2. 8 small squares. This is 1, 2, 3, 4, 5, 6, 7. This is number 8. Okay? Is it fine with
okay.
you? So, again, there is no one way which
Yes.
is right and one way which is wrong. You go with what you are comfortable with. Is that okay with you, Dean?
Yes.
Okay. Then our time is going to end, but we are going to come back in 10 minutes, okay?
Okay.
Can you hear me now?
Yes.
Okay. So you kind of now know how to do a presentation on a graph plot, right?
Yes.
So to save time, I did the graph plot now. This is what I got for myself. You can see it over here.
Yes.
Okay, good. So now we are done with this part. Determine the gradient and intercept of this line. So for the gradient, we have to make a right angle triangle, right?
Yes.
Okay, good. So this is the right angle triangle I'm going to use. Let me check. From where should I use it? Okay. Okay. So this is the right angle triangle I'm going to use. Okay. So this point here, okay, it is going, or this axis, or the x-axis is going to be 2, right? This one is going to be what? This point.
0.81.
Sorry?
8.1.
8.1, right. So here it is 8.1 minus 2. Okay. What about the y-axis? What is this point? It is 2 on the x-axis.
0.855.
0.855, exactly. And what is this one? 0.50. So the gradient, it is going to be gradient is equal 0.855 minus 0.50, right?
Yes.
Divide
Divide
8.1 minus
8.1.
2. Is that right?
Yes.
Okay. We do the math and we get 0.058. Is that correct?
Yes.
Okay. Are we done with the gradient? Are we done with the gradient, Dean?
Yes.
No, we are missing something. You have to be cautious over here. Look at this line. How does it stand? Looks like this, right? This is
Yes.
this is a line with a negative gradient. This is a line with a negative what? Gradient.
Gradient.
Yes. So we got a positive value over here. So we just put a negative value. So the gradient is minus 0.058. 0.058. Okay. Are we done?
No. From the gradient, yes.
No, not yet. What are we missing? The units for the gradient. It is going to be the
The
unit for,
gradient have units.
sorry?
Does the gradient have units?
Yes, gradient got units. Gradient got units, the intercept got units. Why does it got units? Because let us see. Cosine theta, does it have units?
It doesn't.
Doesn't. But 8.1 minus 2, does it have units?
Yes.
Yes, millimeters. So something without units divided by millimeters, we are going to get 0.058 millimeter minus 1.
Okay.
Okay? Is that clear?
Yes.
Be careful with the units. Now, we go to the intercept. Can we take a reading for the intercept from the graph?
No.
No. Why?
Because the graph doesn't start from 0.
Because the x-axis doesn't start from 0. Then what we're going to do? We're going to use an equation. Y is equal mx plus c. C is intercept. So c is equal y minus m X. Okay. Do I know M? Yes, I know M. M is equal minus 0.058 millimeter minus 1. Do I have values for Y and X?
Yes.
From where?
From the graph or the table.
We are going to get it from the graph. We don't get it from the table, okay? Because, can you see? I'm going to show you why don't we get it from the table. Can you see this point? This one. Can you see it?
Yes.
It is a little bit further away from the line, right? So it is
Yes.
not recommended to pick one from the table. It is always better to get one from the line. So the point I'm using, it is around, this is 0.1, 0.2, 0.3. I'm going to use this point. 0.1, 0.2, 0.3, 0.38, 0.75. You can definitely use any other value, right? As long as it is on the line.
Right.
Okay? But this is my choice. Now we substitute. So what is Y? We are going to use this value. 3.8 and 0.75. So this is Y and this is X. So Y it is 0.75 minus, what is M?
Minus 0.058.
Minus, and minus is going to be plus 0.058. What is X? Is 3.8. Okay? We do the math here and we get 3 is equal 0.97. 0.97. Okay? Do you think
Okay.
how to use this equation?
Yes.
Okay, good. Now, are we done with the intercept?
No.
What do we else need to do?
The unit.
Sorry?
The unit.
The units. The intercept always get the units of the y-axis. The intercept always has the units of the y-axis, right?
Okay. Yes.
Okay. So the y-axis, does it have units?
It does have units.
It doesn't. The y-axis. It is a cosine theta.
Okay.
Okay, so it is cosine theta, it doesn't have units. So we are fine. Okay. So let us proceed. Okay. Now we are going to part E. It is suggested that the quantities theta and t are related by the equation. He gave us an equation telling us how they are related. Cosine theta and t, where A and B are constants. A and B are constant. Using your answer is so, determine the value of A and B. Give appropriate units. So the way to do that is write the equation of the straight line. Y is equal
MX plus T.
T plus mx. Do you know why did I write it this way?
To be in the same
Yes,
arrangement as the equation.
exactly. To arrange it the same way as the equation. Why did I arrange it that? Because T is our independent variable and this is our dependent variable. Okay, so I arrange it this way. So now I could see that B is the gradient, or minus B is the gradient. Sorry. And C is the intercept. Is it clear?
Yes.
So what is the gradient? What did we get for the gradient? Minus 0.058 millimeter minus 1. What did we get for the intercept? It is 0.97. So B, we have a minus and a minus, is going to be a plus in A intercept, yes. Sorry, here A intercept. So A, it is going to be 0.97 without any units, and B, it is going to be the gradient or minus the gradient, 0.058 millimeter minus 1. And I think we are done with question number 1. Was that clear for you?
Yes.
Okay. Now we go to question number 2. In this experiment, you will investigate the force acting on a magnet. You have been provided with some of the apparatus already assembled. Can you see this word? Already assembled. So in this part, some of the instrument will be already assembled for you. As shown. He's going to give you the apparatus as shown. Measure and record the height H naught of the end of the pointer above the bench. So what are you going to use to measure the length H naught?
Ruler.
Yes, a meter ruler. Most probably are going to get a meter ruler to use. Okay, so this is how you set it up. And you take a measurement. Okay, again, show him that you have taken 2 readings. Show that you have taken 2 readings. Okay? Okay. What are we going to get? Which one
The
are going to
average.
average? Okay. What if you carry 2 readings? Oops. You did 2 readings. And they came up to be the same. This could happen, right? You took the first reading,
Yes.
it is 36.2 centimeter. Okay, then you are going also to report the average, which is the same. Okay, now
I will say 36.2 plus 36.2 divided by 2.
yes, it is going to be just 36.2. You don't have to do much calculation, right?
Yes.
But what I am telling you, we are going to see it for later. What if I get 2 values to be equal? This is going to be important when we are going to calculate the absolute error or the percentage error. Now he asks us to hang a magnet, okay, and take another 2 readings. We did that and we got those 2 values. Again, we show him that we had 2 values and we calculated the average. H is equal to 34.5 plus 34.1 divide 2, and we get 34.3 centimeters. The units are important. We don't. Okay. Now, calculate the deflection caused by the magnet using this equation. Okay? We already have H0 and we have H, right? So it is 36.2 minus 34.3, which is going to be 1.9 centimeters. Okay. Estimate the percentage uncertainty in your value of dm. Show your working. I did send you yesterday, I think, a video telling you how to calculate the error, right? Or the absolute error in such an equation, right?
Yes.
Can you tell me what is going to be?
It will be delta H naught divided by H naught.
No. If it is addition of two values or subtraction of two values, it is simple. It is delta M is equal to delta H0 plus delta H. Okay?
Okay.
Okay. If it was A times B, then what you are saying is right. Delta C over C is going to be delta A over A plus delta B over B. But now those are addition. So what is delta H0? How we calculate? Do you know?
By the smallest number.
How?
I will say it is 0.1.
0.1? No. How did you get it? So, if we have two values, like in our case, and the two values are different, the two values are different, and we got an average value. So, delta H0 is equal maximum minus average. What is the maximum? What is the average?
36.0.
So what is delta H0? 0.2 centimeters. Okay? The same for here. We have two different values and we have an average. So what is delta H? It is going to be maximum minus average equal 34.5 minus 34.3. It is 0.2 centimeter again. Okay, so delta H0 and delta H is 0.2 plus 0.2 centimeters. Is that okay?
Yes.
Okay, good. Now we are back if the two values are equal. So it is going to be 36.2, 36.2. The average is again 36.2. Should I say that delta H is equal to 0?
No.
No. What in that case, be careful here. In that case, we are going to go and quote the uncertainty of the instrument. So what is the uncertainty in measuring any length using a meter ruler? Do you remember that?
0.1.
0.1. So in case you got two values which are equal, okay, In that case, we go and use the uncertainty in the instrument. What if I was a little bit lazy and I only calculated one value? What is the uncertainty now? What do you think?
Is the one value?
Sorry?
Is this the one value that you calculated?
Yes, this is going to be, but what's the uncertainty? Which one I should use? So if you have only one measurement, if you were kind of lazy or you didn't have time to carry two measurements and you quoted only one measurement, then the uncertainty is going also to be the uncertainty of the instrument. Okay?
Okay.
Keep those points in mind because the whole of question 2 is actually about this kind of calculations. So in our case, we have 0.4 centimeter. Okay. Now, he is asking about the percentage uncertainty. So it is going to be delta dm divide dm by 100.
Multiply 100.
So it is 0.4 divide 1.9 times 100. Okay. What I didn't get is it's something like 1.1%. Okay. This is what I got, I think. Now, let us go to the next step. You have been provided with a card showing the mass m of the magnet in grams. So he already gave us the mass. We just need to report. Determine the value of mass in kilogram. Well, it is, we just quoted 15 milligrams, or 15 times 10 to the power minus 3 kilograms. Calculate S using this equation. Do we know M?
Yes.
Yes, we already have it. Do we know G? Yes, he quoted for us. Do we know dm? It is 1.9 centimeters. But look, we have over here in this one, it is Newton, kilograms. Okay, the mass is in kilograms. Then the best thing to do is to quote this value of dm in meters. So it is 1.9 times 10 to the power minus 2, right?
Yes.
Okay, we need to make all our units consistent. We do the calculation and we get something like 7.74 Newton per meter. So it is 7. I'm going to report it 7.7 Newton per meter. So now the question is, why did I report it as 7.7 and not 7.74? What do you think?
Because you use the instrument uncertainty.
Sorry?
You use the instrument uncertainty.
No. This is how you answer this question. Okay? How many significant figures are here in this number?
Why? Is this 2?
No. You cannot see it. It's 7.74. This one. How many significant figures?
3.
This is 1. This is 2. This is 3. Okay. What about this one? It has got 2
2.
significant figures. So why did I use two significant figures instead of three significant figures? The answer is here. Okay? Go back and check the values that you have used to calculate S. We used M, right? And we used D, right? Those are the values that we used in the calculation. How many significant figures
Yeah.
are here and there?
Two.
Here is two significant figures, and here is two significant figures. So our final result should have the same number of significant figures as the smallest number of significant figures in our question. So in this case, we have 2 and 2. So we are going to quote our value to two significant figures. What if we used to have 1.94, for example? How many significant figures are here?
Three.
3. How many significant figures are here?
Two.
2. Again, we are going to report it to two significant figures equal to the same number as the significant number and the number with the least significant figures. Is that clear for you?
Yes.
Okay. Then we are going to say we are reporting to two significant figures for S to be consistent with the number of significant figures in M and DM. Okay, this is how you answer this part of the question.
Okay.
Now you have been provided with a wire coil wound around the tube. Okay, we are not going into details of how he's carrying the experiment. Again, we have to take two values for H and one value for the current I. We are not getting into detail of how to carry the experiment. Again, which value should we use? The average.
The average.
We again go over here. We again have to take two values. And we have value for the current. You are going to use an ammeter to take the current, and here are the values. Now it is suggested that the relation between SH and capital H and I is this and that, where K is a constant. Using your data calculated to calculate two values of K. So can we do a calculation for two values of K?
Yes.
Yes. Why? Because we have one value over here and another value over here. So we can use the equation twice to calculate K. So what is K? Is simply S capital H minus, small h minus capital H divide I.
Divided by I.
So we substitute. We have two values for K. We have two values for H, right? We have S is equal, we know it from before, we have calculated, 7.7 Newton meter minus 1. We have H equals 34.3 centimeter. And we have capital H 30.1 centimeter. I is equal 0.69 centimeter. This is one set. We have another set which is 30.1 and no 32.2 and 0.32 for I. Okay, then we substitute twice. K1 is equal 7.7, 34.3 minus 32.2 divide 0.32. I need to change this into meters.
32.
Minus 2. Okay, then I do the calculation. I get 0.51 Newton amps minus 1. Okay. Again, this one, K2, say K2, I get 34.3 minus 30.1 divide 0.69, multiply by 100 minus 2 to change it to meters. I got it 0.47 Newton A minus 1. First value of K. So first value of K is 0.51 Newton amps minus 1. The second one is 0.47 Newton amps minus 1. Okay. So did you know how to get these results? We get
Yes, I got it.
equation. We have two values, two sets of values, then we calculate the equation. It is suggested that the percentage uncertainty in the value of K is 20%. Using this uncertainty, explain whether your results support the relation in D. So how we calculate it? We are going to calculate the percentage uncertainty in K. Okay, how do we do that? We calculate the average. Okay? We calculate what? The average value. What is going to be the average value here? It is 0.51 plus 0.47 divide 2 49 Newton amps minus 1. We are going to calculate delta K. What is delta K? It is always max minus average. What is the maximum value? Right?
Yes,
And what is the average?
0.49.
Okay, it's going to give us 0.02 Newton amps minus 1. Then, what else? We need to calculate the percentage uncertainty, which is delta K divide K multiply by 100.
Yes.
So delta K is 0.02 divide 0.49 times 100. We are going to get 4%. Now, how do we answer this? Since this value is smaller than the value he quoted here, then what we are going to say, yes, the results supports the relationship since the percentage uncertainty in K is approximately 4%, which is less than
20%.
the 20% quoted or allowed. Okay? This is how you answer this one. You calculate the percentage uncertainty. To calculate the percentage uncertainty, we need to calculate the average.
Yes.
Then we need to calculate the absolute uncertainty, which is always the maximum minus the average. If the value is less, then you say yes, the result supports the relationship. Why? Because the uncertainty in K is 4%, which is less than the quoted value. Does it always have to be this way? No. You might get a relative uncertainty or a percentage uncertainty which is higher than the value allowed. Then how you are going to answer?
I will say no, the result does not support the relationship.
Exactly. You might, in your exam, some of the students might get the value to support their outcome. Yours might not support. Are you wrong? No. As long as you have followed the instruction and carried out the measurement as instructed, okay, then you should be fine. So, as long as you have carried all the instruction as instructed, okay, some students might get the result as yes, it supports. Some other student might not get it. Are I am wrong? No. Why? Because I followed all the instructions as given. I have calculated everything as I was told. And this is what was wrong with me. Maybe I was not very accurate when I was carrying the measurement. Okay? Sometimes a very little change in the measurement might get us to in this conclusion. So, do you understand this point?
Yes.
Okay. I think our time goes off again. So we wait for 10 minutes and we got our final result. I think next time we are going to go faster. We don't have to explain. So this is the last part of question number 2. And this is how it goes. Describe 4 sources of uncertainty or limitations of the procedure of this experiment. For any uncertainties in measurement that you describe, you should state the quantity being measured and a reason for the uncertainty. So this question is a standard. Okay. The first one, which you can write it in any question of this type. Okay. Remember how many readings did we have for the H and K? Do you remember?
What did you say?
How many values did we get for K?
2 values.
2 values. Okay. Then we are going to say 2 readings. He's asking about the limitations or the uncertainties in our experiment. So 2 readings are not enough to reach a valid conclusion. Is always going to be the case. This is always going to be the case. Again, here you have to be a little bit creative. Okay? What do you think some of the uncertainties or the difficult things that you might encounter in such an experiment?
Zero error.
Maybe, but zero error we can always count for. So when you are going to carry out the experiment, you are going to see that some of the values you measure might be a little bit difficult to carry out. Okay, then you are going to mention those. For example, difficulty to measure the height h. Okay, one difficulty might be, or at least for me, it was measuring the height h using the meter ruler. It is not very accurate. Sometimes the spring oscillate a little bit. So this can be one difficulty. Okay. Another difficulty, magnet hits side of tube, for example. Those are not kind of standard answers. As you carry out the experiment yourself, you can describe what difficulties you have faced. Okay?
Okay.
Ammeter reading fluctuates. Fluctuates means that it doesn't show one single value. It might go a little bit up and down. Okay? So here are the four. But the
Okay.
standard ones that you can always write this one. Okay? So we answer this part. Describe 4 improvements that could be made to this experiment. You may suggest the use of other apparatus or different procedure. Now, the answer to this question are always comments, okay, or how we can solve the problems that we mentioned above. So 2 readings are not enough, take more readings. Take more readings. At least 6 sets of values and use a graph plot to get final result. Okay, remember always what we write here is kind of a response to what we have written above. So 2 values are not enough. The answers take more reading, at least 6 sets of values, and use a graph plot to get final result. Difficult to measure the height h. Okay, we can say that use a pointer to help take a better reading for the height. I said magnet hits side of a tube. Can you see the tube over here? We have a tube over here. This is what I was referring to. Okay. And I said that the magnet, while it is moving inside the tube, it is hitting the side of the tube. So how to improve? I recommended use a wider tube. Okay. The last one, ammeter reading fluctuates. Make sure to use that. Sorry. To sure that all wires are tight. Okay. Or use a more stable power supply. So the answer to those two questions, you have to be a little bit creative. You have to be a little bit attentive while you are carrying the experiment itself to see which parts were a little bit challenging. Then you can explain this challenge and how you think that you can improve the value. Okay, how you can improve the outcome. Is that okay?
Okay.
Okay.
Yes.
Again, the more we solve the exams, the more things are going to get easier. Okay. I will again send you a recording
Okay.
of this session. Okay. Make sure to go through it again. And if you have questions, you can sure ask me. I will send you a homework, typically about graph plots, because those are the most time consuming. Okay. And then see you next Monday. Okay.
Okay, thank you.
Okay. Cheers.